In this video, we're going to look at how you can use the law of cosines to solve for missing sides and angles of oblique triangles. Again, the word oblique just means you have a non-right triangle, which is a triangle without a right angle in it. Again, when you label your triangle, you're going to label your vertices with capital letters, and then your sides are going to be lowercase letters that match your capital letters, but directly across the triangle from your capital letters. So this is the law of cosines over here. It's the side squared equals, and then the two other sides squared added together minus 2 times those two sides times the cosine of the angle that you're given. So this formula changes based on which side you're missing and the information that you have. So if I want side A, I would use this formula. Side B, this formula. Side C, this formula. We're going to use the law of cosines when we have a side, side, side triangle. So when all three sides are given. Or when we have a side angle side triangle, which means we have two sides given and we have an angle given, and that angle that's given is directly between the two sides that are given. So these two types of triangles are where we're going to use the law of cosines. Okay, so let's jump right into a couple examples. So for our first example, let's look at side B being 15 centimeters, side C being 30 centimeters, and angle A being 50 degrees. All right, so if we draw this out and we label our triangle ABC, that would put our 50 degrees down here. That would put our 15 centimeters across from angle B, so 15 here, and our 30 centimeters across from angle C, so over here. Okay, so if you look at this, you do have two sides and you have an angle directly between the two sides. So this is a side angle side triangle. Okay, so looking at what we have little b, little c, and big A. Okay, so looking at the formulas, we have little b, little c. So we have these pieces of information right here and big A. So the only thing we can do is find little a. So we're going to start right here. We're going to find side A. Okay, so we have a squared equals 15 squared plus 30 squared minus 2 times 15 times 30 times the cosine of 50 degrees. All right, so you can go ahead and type this entire string in your calculator at one time. So 15 squared plus 30 squared minus 2 times 15 times 30 times the cosine of 50. Make sure you're in degree mode to type all this in. And you're going to get 546.49 and then a bunch of decimals. So it's really important on these problems that you carry out at least 4 decimal places. That's going to be a rule of thumb to keep your answers accurate, because this is not our final answer. We still have one more step. So if you don't keep at least 4 decimal places, your answers will not be accurate. So we have 546.4912 because that 5 is going to round the 1 up. Okay, so our next step to get rid of this square would be to square root both sides of the problem. Okay, a square root is the same as raising something to a 1/2 power. So I'm going to raise this to a power of 0.5 for 1/2. And that gives me 23.3772. Now, for my final answer, depending on what your instructions say, whether you're asked to round to a whole number or the nearest tenth or whatever, you can go ahead and write your final answer down. I'm going to round to the nearest tenth. For now, 23.4 centimeters. I'm going to go ahead and box that in as my final answer. But notice I went ahead and carried out 4 decimal places because I may need to use this decimal to find something else in the problem. And so I want to make sure I have all 4 decimal places in case I need to use that answer again. Okay, so I have found little side A, which would go here, 23.3772. Okay, at this point, some students choose to switch over and use the law of sines now, because at this point you have a side-side angle or side-side angle triangle if you want to do that. However, I would advise against it, and here's why. When you switch over to the law of sines, remember that whenever you find an angle using the law of sines, and you do the inverse sine in your calculator gives you one angle for the law of sines in quadrant 1, although there could also be an answer in quadrant 2. So unless you have made sure when you do the law of cosines that you found the biggest angle first, which we don't know if this is the biggest angle. In fact, we know it's not the biggest angle, because the biggest angle is always opposite the largest side. So angle C is actually the biggest. Unless you know you have taken care of your obtuse angle first, when you switch over to the law of sines and you do your inverse sine, you don't know if you're finding the sine angle. You don't know if you're finding the angle in quadrant 1 or quadrant 2, and you could end up getting the wrong answer. So my advice is, when you're doing a law of cosine problem, go ahead and finish it out with the law of cosines, unless you know for sure that the angle you were given here is your obtuse angle. Otherwise, when you switch over, you don't know if you need your acute or obtuse angle when you're doing law of sines. So I would stick with law of cosines just to be safe. So we have found little a. Okay, the next thing you want to do is find one of your angles. You can go for angle B or angle C. I typically like to go for the obtuse one, or not necessarily obtuse, but the biggest one first. So if I look at my 3 sides, my biggest side is 30, which means my biggest angle must be angle C. So I typically go with that one next. So I'm going to find C next. Okay, if I'm going to find C, that means I'm using this formula right here. Okay, so that means C squared. All right, C was 30, so 30 squared equals A squared plus B squared. So here's where I'm using this A value, and I want to use all 4 decimals of it, not just 23.4. 23.3772 squared plus B squared, which is 15 squared, minus 2 times A times B times the cosine of C. Okay, now this time what we want to find is actually over here in the work of the problem. So we can't just type everything straight into our calculator. We have to do a little bit of solving first. So what I would suggest is go ahead and work this part right here out. Get a value for that, because whatever we get for that, we're going to have to subtract it over to the other side. Okay, so we have 23.3772 squared plus 15 squared. Get that value. So I have 30 squared equals 771.495 for that value. Okay, and then if you want to, you can go ahead and get this value right here. Okay, 2 times 23.3772 times 15. And that's 701.316 times the cosine of C. Okay, so basically what I've done here is I have simplified this term of the problem, and I've simplified this term of the problem. Okay, I can't put them together. They're not like terms because this one has a cosine attached to it. Okay, so I can't combine them, but I've simplified them. All right, so next what we want to do is, because we're trying to get this by itself, this term right here needs to be subtracted over to this side of the problem. So we're going to do 30 squared minus 771.4935. Remember, I'm keeping 4 decimal places all the way through the problem. And I get 128.5065 equals negative 701.316 cosine C. Okay, and then our last step, well, almost last step, we're trying to get cosine C by itself. We've got to get rid of this number. Since they're sitting side by side, that means multiplication, so that means we're going to divide by that. divide by negative 701.316. Divide by negative 701.316. And it gives us negative 0.1832, those canceled, equals cosine C. Okay? All right, we need angle C. Remember, the only way you can split an angle from its trig is to do inverse. So to get C, I need to do the inverse cosine of negative 0.1832. So that's the last step in your calculator. Second cosine, to get the cosine inverse, negative 0.1832 gives me 100.6 degrees for angle C. 100.6 degrees, and it is an obtuse angle. So that goes right here. It's not drawn to scale, obviously. 100.6 degrees right there for that corner of the triangle. Okay, now the only thing left to find is angle B, and this one's easy because the three angles of a triangle have to equal 180. So now to find B, all we have to do is take 180 degrees and subtract the 106 or 100.6 that we just got minus the 50 that we were given for angle A. So we've got 180 minus 100.6 minus 50, and that one is 29.4 degrees for angle B. Okay, so when you do the law of cosines, you're going to have two somewhat difficult steps, but then that last one's going to be easy when on a side angle side example.